as another example of how we can use molarity, and actually this is a really common question that if you're preparing solutions in a lab, you need to answer is, you often have a volume of a solution that you need. You need, say, 100 milliliters in this example that I have here, and you know the concentration you need. The protocol you're following says, I need 0.125 molar solution. That's what a previous researcher used, and that was a good concentration for whatever reaction you're trying to run. And so we know that we need 100 milliliters. We know we need it to be a specific concentration, 0.125 molar, and of a particular compound. In this case, I've got ammonium chloride, but this could be anything. How much ammonium chloride do we need to weigh out? What mass of ammonium chloride do we need to make this one and then dissolve it up to 100 milliliters? The way this would work in the lab, just so you know what it would look like, is that you would weigh out your ammonium chloride. That would be in some sort of container that you would weigh on a balance. And then you would use what's called a volumetric flask, which I think you have been introduced to in the lab. Use a 100 milliliter volumetric flask. Your ammonium chloride will go in first. Sorry about that notification there. But your ammonium chloride will go in first, and then you will add water and fill this up to the line, and that will make your 100 milliliters of solution. So the question is, on this step over here, how much ammonium chloride do we need to weigh out? All right, let's figure this out. So we got a few steps we're going to have to go through. So what do we know? We know that we have a volume of 100 milliliters. We know we have a concentration. The molarity is equal to 0.125 moles per liter, just writing that out explicitly. And here, what we mean here, what? Moles of ammonium chloride. So using what we saw in the last video, if we multiply these together, if we multiply molarity times volume, that'll give us our number of moles of ammonium chloride. And then once we're there, we know what to do with that. We can take a number of moles of ammonium chloride and convert to grams of ammonium chloride using the molecular mass. All right, so let's go ahead and do this. So our moles of ammonium chloride is equal to 100 milliliters. We're going to need to, again, convert this just like we did on the previous slide, or previous page, video, to liters. So by dividing by 1,000, and I know it's dividing by 1,000 because there's 1,000 milliliters in every liter. And then we will multiply this by the concentration, 0.125 moles per liter. I'm just going to slide this to the side so we have enough space. And we can go ahead and calculate this. And that'll get us to our first step, which is how many moles of ammonium chloride does this correspond to? So pulling up the calculator, we get 100 divided by 1,000, which is 0.1, times 0.125, which gives us 0.0125. And that's how many moles of ammonium chloride we need. And then step 2 is what we already learned to do in chapter 3. We can take our number of moles and convert it to a mass. So our 0.0125 moles of ammonium chloride. We need one more piece of information here, and we'll need to use the periodic table to do that. But we need to find the molar mass of ammonium chloride. Right, and I'm going to go ahead and do that on my calculator here. You can't see, but I got my periodic table right to the side over here. I'm going to pull up the calculator. So we're going to need 1 nitrogen. Nitrogen is 14.007. We're going to need 4 times hydrogen, 1.0079, and then 1 chlorine, which is 35.453. So if we add all those up, we get 53.492. Just rounding a little bit, grams per mole. That's the molar mass of ammonium chloride. And so we're going to use that in this calculation here. And in this case, we need moles in the denominator, and our grams will be in the numerator. So we can put our 53.492 grams up here and do this conversion here. So 0.0125 times 53.4916 gives us 0.669 grams of ammonium chloride. So if I were in the lab, I would grab my bottle of ammonium chloride, use the balance, weigh out 0.669 grams, get it as close as I can, and then I would pour that into my volumetric flask, fill it up with distilled water up to the mark, and vigorously mix it, and then I would have my 100 milliliters of a 0.125 molar solution of ammonium chloride. So this is an example. This is trying to relate these ideas that we've already talked about to a very real-world example and a calculation that I still do. Anytime I need to prepare a solution, I do this exact sort of calculation and then prepare the solution, just like I described. So hopefully that was helpful, and to see how these ideas we've already talked about with stoichiometry also relate to when we're thinking about solutions.